Hey, welcome back to our series on Go. Today, we're going to unlock one of the most fundamental concepts there is. This is the thing that will literally transform your code from a simple script into a powerful, organized application. We're talking about functions.
You're with Mira Developer by Mira World. Now, if you've been following along with us, you've already gotten the hang of variables, conditionals, and loops. Well, now we're going to tackle the tool that brings it all together. This is the absolute key to organizing, reusing, and scaling your code.
So here's our game plan. We'll kick things off with the what and the why. Then we'll get our hands dirty with Go's syntax. After that, we're covering how to return values and how Go has this really unique approach to handling errors. Then it's your turn to put it into practice with some exercises. And finally, we'll zoom out to see the big picture of why functions are so critical. You ready? Let's do this. Okay, first things first. What in the world is a function? You hear this term all the time, right? Well, at their core, functions are the absolute building blocks of any clean, organized, and efficient code. Let's break down exactly what that means.
You know, the best way to think about a function is like a specific tool in a toolbox. You've got a hammer for nails, a screwdriver for screws. Each tool does one job, and it does it really, really well. A function is exactly that. It's a named, reusable chunk of code that performs one specific task. That task could be anything: calculating a total, logging in a user, sending a notification. The function handles that one piece of logic for you.
And wow, this slide just says it all, doesn't it? I mean, look at the left. That's the messy reality of just copying and pasting code over and over again. It's inefficient and it's a headache to manage. But on the right, we've wrapped that logic up into one single function. Now it's clean, it's easy to read, and the best part, if you need to change that welcome message, you only have to change it in one place. That is a game changer. And this really hammers home the core benefits. First, functions help you reduce repetition. You'll hear developers talk about the DRY principle. Don't repeat yourself. This is it. They also help you organize your code into these logical, manageable pieces. And because of that, your programs become infinitely easier to fix and maintain, and way more readable for you and anyone else who looks at your code.
Okay, theory is great, but let's get practical. Now we're going to look at the nitty-gritty syntax for actually writing functions in Go. We'll start with the most basic structure and then see how to make them dynamic with something called parameters.
All right, here it is. This is about the simplest function you can possibly write in Go. But here's a super important point. Just defining this function doesn't do anything. It doesn't run the code. It's kind of like writing down a recipe for a cake but never actually going into the kitchen to bake it. To bring your function to life, you have to explicitly call it by name.
Let's break that syntax down piece by piece. Every single function in Go starts with the func keyword. That's how Go knows you're about to define a function. Right after that comes the name you give it. In this case, say hello. Then you have these parentheses. That's where you put your parameters, and we'll talk more about that in just a second. And finally, you have the curly braces, which wrap the function body. That's the actual code that's going to run when you call the function.
This is where functions start to get really powerful. We can make them accept data using parameters. So here, our greet function takes one parameter called name, and we're telling Go that it has to be a string. Now, when we call the function, we can pass in different values, like Alice or Bob, and the function's behavior changes. This makes our code way more flexible and reusable. And hey, you're not limited to just one parameter. You can pass in as many as you need. But check out the syntax here. Func add a, b, int. This is a really common shorthand in Go. Instead of writing out a int, b int, if you have a bunch of parameters in a row that are the same type, you can just list their names and then put the type once at the very end. It's one of those little things that makes Go code so clean and readable. So far, our functions have kind of been a one-way street, right? They perform an action, like printing to the screen, but they don't give us anything back. But what if we need a function to do a calculation and give us the answer? This is where returning values comes in and where we're going to find one of Go's special superpowers.
Okay, look really closely at the function signature here. Func sum a, b, int. See that last int right before the opening curly brace? That's new. That's us telling Go, hey, this function is going to give you back an integer. Then inside the function, the return keyword is what actually sends that value back to wherever the function was called. Then we can catch that value and store it in a variable just like you see here with result.
And now for that Go superpower I was talking about. Unlike a lot of other programming languages, Go functions can return more than one value at a time. It's awesome. In this divide function, we're returning two things, the quotient and the remainder. Notice how the return types are wrapped in parentheses now. Int, int. When we call it, we can grab both of those values and assign them to separate variables, all in one clean line of code. This is a huge, powerful feature in Go.
So this ability to return multiple values leads us straight to one of the most important ideas in all of Go. This quote right here says it all. In Go, errors are not exceptions, they are values. This philosophy literally changes everything about how you write reliable software.
And here's what that looks like in the real world. Our new function divideSafe returns two things, an integer and something of type error. Now, if something goes wrong, like someone tries to divide by 0, we don't crash the program. Instead, we return a 0 for the result and a new error object that explains what happened. But if everything goes smoothly, we return the calculated result and nil, which is just Go's way of saying, no error here, all good.
Pay close attention, because this slide shows the single most common pattern you will see in Go code, period. You call a function that might fail, and you get back two things, the result and a potential error. The very first thing you do, always, is check if that error is not nil. If it's not nil, it means something went wrong, and you handle that problem right then and there. If it is nil, you know it's safe to use the result. This simple pattern is the key to building rock-solid Go applications because it forces you to deal with problems head-on.
All right, that was a lot of theory. Now it's time to actually get this stuff into your fingers. You know, the best way to really learn to code is by, well, coding. So let's move on to some hands-on exercises.
Okay, it's your turn. No, seriously. Go ahead and pause this explainer, open up your code editor, and give these a shot. Start with the multiply function, then tackle isAdult, and if you're feeling up for it, give that mini challenge a try. Don't worry, I'll be right here when you get back. So whether you breeze through those exercises or are just following along, let's take a step back for a second. Let's zoom out and connect all these dots to the big picture. Why is getting good at functions so absolutely essential for any serious software developer?
Well, the truth is, pretty much every single piece of real-world software you use every day is built on functions. The APIs that let your apps talk to each other, the systems that log you in securely, the services that process your payments, the code that validates data, even entire architectural styles like microservices. They're all just made up of lots of small, well-defined functions working together to do amazing things.
And that leads us to a core principle of good software design. The best developers don't write these huge 1,000-line monster functions that try to do everything at once. No way. They write small, focused functions that do one job and do that one job really, really well. This discipline is what makes code easy to test, easy to debug, and easy to reuse. It's the secret to building applications that last.
Let's do a quick recap of everything we accomplished today. You now understand not just what functions are, but why they're so important. You know how to define them in Go, how to pass in data with parameters, how to get results back using single and multiple return values, and you've seen the official Go way of handling errors. That is a massive step forward on your journey.
So if this explainer helped you out, I'd really appreciate it if you'd hit that like button. And hey, I would genuinely love to see your solutions to the exercises down in the comments below. And of course, make sure you subscribe to Mira Developer so you don't miss our next lesson. Thanks for watching and happy coding.